We're going to talk about radical expressions today and how to simplify those so we can get ready to add, subtract, multiply, and divide with them. First thing you need to do is go back and review what are perfect squares. You should know the perfect squares from 1 through at least 13, okay? Take a minute to try to write them down and then check them, okay? Pause the video. Now let's check to see what you have. The smallest perfect square is 1, okay? And then there's 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. You should at least know those. That's up to 13 squared. Okay, you should at least know those. So you can go on further, but those are going to be ones that you're going to need to be able to recognize. Okay? All right. An expression that contains a radical sign is called a radical expression. That square root symbol is called a radical. When you just see the radical sign, you know it belongs to square roots. Other roots are written with a little number up in there, which is called the index. So when you see the radical sign with a 3, that means the cube root. Okay, you're going to see radical signs written in a lot of different ways. Let's move that down. So here are some. This is the square root of 14, the square root of L squared plus W squared. You'll notice that that's a binomial underneath there. The square root of 2GD, the square root of D divided by 4. All right, you see these. The expression underneath the radical sign can be a number, it can be a variable, it can be a combination of those. It can also be one term or more than one term. So you're going to see all different kinds. Okay? We're going to ask you to simplify your radical expressions. The part underneath the radical sign is called the radicand. You know that it's simplified when the radicand has no perfect square factors other than 1. Everything's going to have a factor of 1, so it can't have a 4 or a 9 or a 25. The radicand has no fractions. You're not allowed to leave fractions underneath the radical sign. You're technically not allowed to have a denominator in there, okay? And there are no square roots in any of the denominators, all right? And we'll talk about that at the very end of this video. Positive numbers have 2 square roots, one positive and one negative. However, when we're just using the square root sign, and I'm not solving for a variable, I'm just saying what's the square root of this, we're always going to pick the non-negative square root. Okay? When you have a variable and you're trying to take the square root, we want it to be the positive, and since we don't know if the variable is positive or negative, you can put it in absolute value. Now, a lot of times you will see it, they'll say that we're going to say that all variables are non-negative numbers, okay? All right, so here's some examples for you guys. Now, when you have stuff underneath the radical sign, we normally want to simplify it first. So for this first one, you've got 2 over 50. Well, that can be reduced, can it? And it can be reduced to the square root of 1 over 25. And we can actually break that apart into the square root of 1 over the square root of 25. And the square root of 1 is 1, the square root of 25 is 5. So the square root of 2/50 is 1/5. In this case, you would want to put them together first. So 8 squared is 64, and 15 squared is 225. And when you add those together, you get 289, and the square root of 289 is 17. Okay? This one's a little bit more difficult. I have a trinomial underneath there. Now, I know the only way to take a square root is if there's something squared underneath there. So I'm hoping that you recognize that this is a perfect squared trinomial, in which case it is factored x minus 3. The square root and the square cancel out, and you end up with x minus 3. Okay? And we're just going to go ahead and assume that the x is going to be a non-negative number, so we don't have to put the absolute value around it. All right? There's a rule called the product property of radicals, which basically says when you have multiplication underneath the radical sign, you can either leave it together underneath the radical sign or separate the factors with each having their own radical sign. Sometimes it works better one way, and sometimes it works better another way. But this is what we're going to use to simplify radicals. When we simplify a radical, it's like reducing a fraction. We've got to find a perfect square factor. So let's look at 24. There is not a square root of 24. But think about your perfect squares that you generated at the beginning and say, is there a perfect square that is a factor of 24? Yes, there is. And that happens to be 4. So we're going to rewrite 24 as 4 times 6. Now, you can leave it like this and just mark through the part that's a perfect square and take it out, take the square root, or you can rewrite it the square root of 4 times the square root of 6. You'll see that's that product property up there. Okay, the square root of 4 is 2, so this becomes a 2, and reduced, this is 2 radical 6. And that's it. That's all there is to this. All right, here we've got one with variables. Remember, if it is an even exponent, then you could take the square root of it. So I'm going to rewrite this as x squared times x, and then this I can leave as y to the 4th. Okay, again, if I want to rewrite it, square root of x squared, the square root of y to the 4th, I put those in the front, and then the square root of x on the end. What is the square root of x squared? X. What is the square root of y to the 4th? Y squared. There is no square root of x, so it remains underneath the radical sign. Okay? Now, sometimes when you do this, you may not see the bigger square root right at once. So in this case, I know that 4 will go into here, but it'll go into here 32 times. Well, 32 is actually 16 times 2, isn't it? This is a perfect square, and this is a perfect square. Okay? So I can take the square root of 4, which is 2. I can take the square root of 16, which is 4. That comes out front. And what am I left underneath the radical sign is a 2. And 2 times 4 is 8. So this would be 8 radical 2. Well, now going back, I realized that I could have broken that up as 64 times 2 to begin with, and then taken the square root of 64, which should have been 8 radical 2. So it really doesn't matter whether you do it all in one step or take several steps to do that. Okay, so pause the video and try the next one. Okay, here's what it looks like when you break it apart. The square root of this is 4. The square root of this is a. There is no square root of 3. There is no square root of b, so I will put them back underneath the radical sign together. Okay? The quotient property of radicals is the same thing. It's just simply saying if you're dividing underneath the radical sign, you can either leave it like that, or you can break it apart into 2 separate radicals. Okay? So in this case, there's nothing I can do to reduce this, so I'm going to break it apart. Radical 5 over radical 4. I can only take the square root of 4, which is 2, so this ends up being radical 5 over 2. As long as you do not have a square root sign left in the denominator, then you are good. Okay? In this case, I'm going to leave it together for right now because I'm going to go ahead and reduce this. M will divide into m third and give me m squared. Now I'll break it apart and make it the square root of m squared over the square root of 9, which is going to give you m over 3. Pause the video and do the next 4. Okay, so here's the work for the other ones. You'll notice on this one I reduced it first, and they turned into nice perfect squares, and I took the square root of those. On this one I broke apart the x cubed into an x squared times x, and then took the square root of 9, the square root of x squared, and the square root of 16. The x remained underneath the radical sign. All right, for this one I broke apart the z to the 5th into the z to the 4th times z, and took the square root of all the perfect squares. Okay, now the last little thing that you're going to run into is what happens when you can't get rid of the square root on the denominator. So here is the square root of 5x squared divided by 3. So I'm going to break it apart, and I realize that the only thing I can take a square root of at this point is the x squared, and that's going to come out as an x. So I'm left with a radical 5 over a radical 3. The radical 5 on the top is fine, but you are not allowed to leave a radical on the bottom. So we have to figure out a way to rationalize the denominator. And we do that by multiplying by the radical on the bottom. So I'm going to multiply the bottom by a radical 3. And to be fair, I multiply the top by a radical 3 also. Okay, so on the top, that's going to give me radical 5 times radical 3 is radical 15. And you have an x in front. Radical 3 times radical 3 is radical 9, but there is a square root of 9, and it is 3. Now you'll notice that there is no more radical sign on the bottom, and we are done.